Hi, my name is Nicholas Lohman. I'm a Partner Solutions Architect at Amazon Web Services. Today I have Rick from Red Hat here with me. Rick?
Hi Nick, thanks for having me. My name is Ricardo Garcia, and I'm a Technical Marketing Manager at Red Hat, and I'm mostly focused on SAP customers.
That's awesome. And today we're going to be talking about automating the migration of SAP workloads on AWS.
Cool. So if you want, Nick, why don't we start defining the different steps that are part of a migration, how they are traditionally done, and how we can do all this with automation.
Absolutely.
We can start so with the infrastructure, right? That would be the first building block of our migration, because we need to build an infrastructure on AWS.
Okay.
So once we have our infrastructure there deployed, we would need to install the operating system, the image of the operating system that we want. In this case, it will be RHEL for SAP solutions. Once we've done that, we need to customize and tune the operating system. Sorry.
No, that's okay.
Like that, yeah. Okay. So once we've done that, we need to install the database.
Okay.
Right.
And database install.
Right. And it will be any of the database supported by SAP. So Oracle, SQL Server, but normally we will tend to do HANA, but let's talk about it a bit more later on. Once we have the deep install, we need to install the actual application. So the SAP application, be it an SAP NetWeaver or SAP S/4HANA. Right. And that's when we have our whole installation done. We still want to do testing, like QA testing, for example, for disaster recovery or in general QA testing, before the systems are handed over to the SAP basis or SAP administrator team that will be handling the system, managing it day to day. So typically, as we said, all these building blocks are done by different teams normally. And what can happen is that these teams have a big pipeline. So there can be bottlenecks. So a team will maybe fail to deliver at the right time the virtual machines, the EC2 instances, whatever, and that will affect the rest of the pipeline, right? So we end up having a bit of a long process here that we can make more shorter with automation. But let's review a bit of the steps on each one of these building blocks if you want.
Okay. So part of our infrastructure is going to be like things like what? EC2?
Correct. You will create your instances.
And then we have our security groups.
Yes.
And then our networking.
Perfect. That's correct. And we move on to the actual OS installation and configuration, right?
Absolutely. So part of our automation here is we're going to use the roles. You want to talk about the roles a little bit?
Yeah, so in the case of Ansible, the automation assets are called roles. So we have roles, we have them playbooks. We'll go into more detail about that in later videos, but just to say, let's call it roles for now. And what we're going to do in the configuration of the operating system, we're going to use this system roles. So these roles, Ansible roles, come with the RHEL for SAP subscription. And what they do is to run or to do all the modifications to the operating system that are defining the OSS nodes. So those are the SAP nodes with recommendations to install SAP HANA, to install SAP NetWeaver, S/4HANA, and run it performantly. So all the compliance part from the side of SAP and from the side of Red Hat will be contained in those system roles that will be applied automatically. So all these modifications will be done automatically, and the SAP basis people, the OS people, won't need to do it anymore manually, because that takes quite a long time. There's lots of recommendations to be run. Apart from that, as you have written there, Nick, you have all the registration of the host to the right repos so that they can access the software that they will need to run, and in order, for example, to run this system roles. And as you said, smart management. That's about connecting the RHEL host, registering them to smart management, which is a lifecycle management solution by Red Hat. You have written insights as well, which is very important, and we will see it later in other videos about operations automations. So Insights is a software as a service by Red Hat that makes sure that the hosts are compliant with Red Hat recommendations, with SAP recommendations. We will see that. And also, you've written hardening, so you can actually apply CIS benchmarks and apply them automatically, because you know that typically a CIS benchmark has a lot of steps, right?
Yeah, there's a lot of security controls. I mean, I wrote hardening CIS, but there's a lot of controls in these security implementation guides. And then the other thing that I wanted to pull up, highlight, is that these roles, who writes these roles? Red Hat writes the roles, right?
So Red Hat, for example, the roles that are called system roles that I just mentioned to apply the OSS nodes are written by Red Hat. They are supported by Red Hat, so that means that they have been officially certified, and whenever new SAP nodes come out for a new version of SAP HANA, for a new version of S4 HANA, whatever, they will be incorporated in the next version of the roles.
That's really great, because so all of these roles they're written by Red Hat and they're supported and certified by Red Hat, which means that, you know, before, when I had to go through a PDF and go through all of these different steps and manually apply, you know, tuning and enable repositories and register and do this hardening, now that's all done through a certified process that's doing it for me. I need to add these to my playbook, and then that's done.
That's it.
And that takes a lot of the human element out of it. So if I do this multiple times, it's going to happen in the same way. I don't have to worry about missing a typo or anything like that.
Yes.
Absolutely.
Yeah, I was going to say, if you've been a system administrator, there's always the issue of you have deployed a system, you have deployed another one. So, for example, you have deployed your production and then your quality system, and for some reason, at some point, they behave differently, and it shouldn't be like that. And you spend so much time troubleshooting and resources, and this might be just because of a configuration drift that has been introduced by human error. So by doing this with Ansible, you make sure what you define and has been tested once will be repeatable, and you will have no configuration drift, so no time spent on troubleshooting the misconfigurations.
That's right. There's going to be a lot of consistency between all of these installs.
That's correct.
And I don't have to worry about making a typo. It's going to be the same way.
That's one of the good things about Ansible that I found really, really interesting.
So let's go on up to our next step right in here. You said this is the database installs. It's probably going to be HANA, right?
Yeah, normally customers tend to, if there are new deployments, they want to deploy on HANA normally. But there's still some other databases that are supported by SAP, like, as I said, Oracle, or SQL Server, MaxDB. All this database will need to, at some point, be changed to HANA, because there's a deadline of 2027 for all the SAP customers to be using the new S4 HANA suite for SAP. So that suite, that new ERP system, only runs on SAP HANA. So that's why, and HANA only runs on Linux. So
2027's that's a deadline that's coming up,
it is.
Fast approaching. So another part of the DB install is our HA, our high availability, which we use with Pacemaker. How many nodes do we need to be able to accomplish HA?
Well, normally it depends on the way you're deploying your SAP HANA database. There are typically two different ways. There's one called Scale Up, for which you only need 2 nodes, the nodes where the primary resources will be at a moment, and the other node to which, if there's a problem with the primary node, the resources will be failed over. There's also another implementation that's called Scale Out, that's having multiple nodes to have more computing power. In that case, if you're doing a cluster with that, you will need to replicate the same amount of nodes that you have on the primary side on the secondary side.
Okay, and using our automation package, so like especially seeing we have to do this to 2 nodes now.
Yeah.
You know, so we're going to use Ansible to do this. So it's both of our nodes are still going to be configured exactly the same because they're being run off the same playbook, right?
Yeah. So will be no configuration drifts whatsoever.
So what about this SAP application install? Right. What else is involved with that?
Yeah. So one thing that's important to say, normally in a production environment, and in most environments, unless it's development or small environment, you will have your database on one server, application installed on another server, completely independent. But still, you can use Ansible for that and do the whole process with this. So in this application install, you will first of all, you will need the software that's going to be installed.
Okay.
Just as with HANA, you will need to do the software. So there are playbooks to download automatically the software that you need using your subscription, your OSS user for the SAP portal, right? And once you have downloaded the software, you can install it automatically with the parameters that you want to. I mean, you can customize your installation as much as you want, which is good. And after that, so you can also, if you want to have high availability at the applications level, you can do it as well. So exactly as we did with Pacemaker for the database, you can have your Pacemaker cluster created for the application, roles for it as well. So you don't need to worry about introducing human error. And that's good here because Pacemaker can be very picky or very opinionated. So it's very sensitive to slight variations of parameters. So I've seen it happening quite a few times before, spending a couple of weeks troubleshooting an unexpected behavior of the cluster. It was because we had maybe introduced, when we did it manually, a shorter time for failover or something like that, just like missing zero.
So here we're going to commit all of those variables to our Ansible playbook,
Definitely.
and that way it's all going to be consistent across
Yes.
there. And we're also, and Ansible can also take, and it'll take our credentials here
Right.
and encrypt those and store those in the Ansible application platform.
Yes.
So that, or Ansible automation platform,
Right.
so that we get all the credentials are stored in an encrypted environment, so they're not out willy-nilly in a bash script or something. We don't want to do that.
And only the right people will have access to those playbooks. We can talk about it later on, about all the role-based access control, all the role-based access control. So yeah, definitely.
Absolutely. And what about testing? What all do we have under testing?
Well, so when you have deployed your new systems or you have migrated your systems, before you pass it on to the SAP basis, to the SAP administration team, they will ask you to run some tests because otherwise they won't take ownership. And it's fair enough. So those tests can be defined in Ansible playbooks as well. You can run them. And once the results are satisfactory, you can hand over the system. Of course, as you're right, Nick, DR testing can be one of the topics and of the applications of this testing.
So we're going to actually do a disaster recovery test and show that when one node fails, the other one takes over.
Definitely.
And so we have some confidence in our infrastructure. We know that we're not just saying we deployed the high availability system. We've actually tested it and got confidence in it that it's actually going to work for us whenever we need it.
Yeah, of course. You can test both the high availability per se and the actual disaster recovery. For example, if you want a proper disaster recovery, when you don't want to fail over automatically as well, so you can test also how the system comes up on the other side when you are ready to bring it up.
Absolutely. And we're going to go ahead and bring up what this architecture will look like when it's deployed as EC2 instances. So we have a primary, and this is a typical HA setup. So we have a primary node right here, and then we have a secondary node over here.
Correct. Exactly the same, right? The same type of EC2
so
instances.
We've taken all of this configuration information and we're applying it to this instance, and we've also applied it to this instance. Right. And then we have Pacemaker.
Pacemaker will be installed on both machines, on both EC2 instances.
And so the Pacemaker makes sure that the machines are, if one goes down, it'll automatically switch over to the other one.
It's correct.
And this primary machine over here is in availability zone 1. And this other secondary machine, it's over in availability zone 2. So it's really important. These two are in completely different buildings.
Yeah.
They're in different locations. They're separated. There's miles between them. And so if a fire happens to one data center, it's not going to affect the other one because they're completely separate. So, and by doing the automation on these, we've configured to make sure that both of these are the same.
Yeah. Mm-hmm.
And so if we were to do all of these steps in a traditional workflow without using Ansible, without automating this, and it's spread across, you talked about the infrastructure team and the SAP admin team. What does the typical deployment timeline look like?
Well, this could be up to 1 week, for example, in average, because as we said, there might be delays between the functions that each team is doing. So let's say around 1 week.
1 week?
Yes.
Okay. Now, and that's with doing this in a traditional manner. Now, if we use Ansible playbook to deploy all of this and test it, what does a typical time look like when even running through the disaster testing and capacity testing?
So that's the best part, because it can be reduced to, I would say, less than 3 hours, because the actual installation can be like 1.5 hours, the full installation of all this in preparation. Then if you run some tests, etc., let's say less than 3 hours.
So we're going from 1 week to less than 3 hours.
Right.
Now that's a tremendous savings. I don't
It is.
Now, let's talk about Ansible for just a minute. Now, this is for one system or one specific workload.
Mm-hmm.
What if I have multiple workloads? And can I deploy, if I were to want to deploy a similar system for 3 or 10 workloads, could I do that at the same time, or does my 3 hours just add up, or how does that work?
No, you can do it in parallel. Completely
So
in parallel.
Ansible can do this all in parallel.
Yes.
So if I wanted to do 10 systems in 3 hours, I could deploy 3 systems or 10 systems in 3 hours.
Yeah, they don't.
And at the end of the 3 hours, I've got DR testing and capacity testing done for all 10 systems at the same point. And how many more people does it take to do 10 systems versus one workload system?
Same number, so just one system administrator decided to run the execution workflow of the playbooks in the different systems, so you don't need more people.
So in this instance, the Ansible automation platform is a mass. It's not only it's giving us consistency through all of our systems, because all of those systems would be exactly the same. Yeah. But it's also empowering our sysadmin to be with a power tool to be able to affect many systems at one time.
Mm-hmm. Yeah.
That is really exciting.
It is a big gain, indeed. Yeah.
Thank you so much, Rick, for your time. I really appreciate it. That was,
Thank you, Nick.
I've learned a lot
today.
Thank you so much.
Thank you.